payments of 15,000 kwacha each, with the first payment to be received 2 years from today, or a single lump sum to be received today. If you can invest at 6% annual rate of interest, what is the least you should accept as the lump sum payment amount? Okay. So the situation here, you win a lottery and you're going to be getting 15,000 every year. Okay. Your first payment is going to be paid to you in year 2 years from today. So year 1 passes, then year 2. Okay, we're looking at today. Year 1 passes, you won't be paid. Then in year 2, that's when you're going to be passed. Then you're going to be paid. Okay, so this is an important point in this question, because this is telling us we're dealing with a deferred annuity. Okay, remember, an annuity is the same payment over the same period of time. Okay, like for example, your salary can be an annuity. You're paid every month the same amount. Okay, so to find this lump sum which we should accept, okay, we have to find the present value of this annuity. Okay, we find the present value of this annuity, and that's going to be able to tell us the lump sum that we're going to get. Okay, so since it's a deferred annuity, this is how the formula is going to be. Here's the formula for the present value of an ordinary annuity. Okay, present value of an ordinary annuity. So we use this formula. The present value equals the cash flows that we're going to be receiving multiplied by our annuity factor here, 1 minus 1 over 1 plus r to the power n. Over r. Now we've got, since this is a deferred annuity, so we're also going to add this multiplied by 1 over 1 plus r to the power d. D is the number of years deferred. Okay, it's the number of years deferred. So since we're going to be paid in year 2, okay, let's think that this is today. Next year we don't get paid, that's year 1. Then in year 2 we get paid. So it means we have a deferment of 1 year. Okay, so we're going to say D, which is our deferment, over 1 year. So D equals 1. Okay, then we just put in our values into the formula. Okay, the equal cash flows 15,000 per year, multiplied by our annuity factor, 1 minus 1 over 1. Our rate is 6%. Okay, so we convert it into a decimal. 1 plus 6% as a decimal is 0.06. Okay, the number of years, it told us 5 annual payments. Okay, 5 annual payments. So N is going to be 5 over 0.06. multiplied by 1 over 1 plus 0.06 to the power 1. Okay. So we do our tabulations. Let me solve the annuity factor here. Okay, so I'll start with this 1 plus 0.06, that's 1.06. Then 1.06, I hope you also have your calculator with you, okay, so that you know how to do this in the exam. 1.06 to the power 5, that's 1.33, okay. 15,000 multiplied by 1 minus 1 over 1.33. Over 0.06 multiplied by 1 over 1.06. Okay. Step by step. So next we're going to say 1 divided by 1.33. You get 0.751. One minus 0.751 divided by 0.06, and then also 1 divided by 1.06. Yes.
So now the confusion comes in
Okay.
on the calculations here.
Okay.
On the division, just here on the R, this part. That's where I get confused.
Okay, madam, first you start with this numerator here.
The top one?
This top one, yeah, you start with this top one. Step by step, okay? Listen how I'm breaking the top one down. Yes. Once.
So this one, the first one is subtracting this whole fraction this side, right?
Yes.
Including the 0.06.
Yes. This one.
0.06. The one down is only for the this function, or it's for everything, including the -1.
That's what. Where are you talking about?
The R. When you go back to the formula, the R is dividing everything on top, including the 1 minus, right?
Yes. After you do this numerator operation, then you divide at the end. Okay. The division has to come at the end. Okay, madam? Yes. Yes, the division has to happen at the end. So just look, just see how that's how I'm breaking it down step by step. Okay. And we have 15,000 multiplied by 1 minus 0.751. 0.249. 0.249 divided by 0.06, okay, multiplied by 0.943. Okay, then you do 0.249 divided by 0.06. Okay, you get 4.15. So 15,000 multiplied by 4.15 multiplied by 0.943. 0.943. Then we now multiply 15,000 times 4.15 times 4.15 multiplied by 0.943. Okay, that gives us 58,701 kwacha 75 ngwe. Okay, this is the lump sum that you should be willing to accept, the least lump sum. Okay, for those who have just joined, we're looking at time value of money. Okay, we just started the topic here.